Okay, for this guy, I've got a simply supported beam with a uniform distributed load on it. It's going to deflect down and actually land on top of kind of a post at B and then compress that. And the equation is, what am I trying to find? Determine the support reactions A, B, and C is essentially what I'm looking for. So as per usual, we're going to start with our statics equations. So I have A, C. I'm also going to have B pushing up on it, and then I've got my distributed load acting down on it. So when I sum my forces in the y direction, I have A plus B plus C minus, and that'll be 12 times 30,000 equals 0. Okay? And then I'm going to sum the moments. Okay? And we'll go ahead and sum the moments about point A. Okay? So I have 6 times B, and I'll have 12 times C, and then I'll have negative 6 times 12 times 30,000. And we'll go ahead and leave that like this for now. Okay, 2 equations, 3 unknowns. I've got A, B, and C that I need to figure out. Okay, so I need to do some deflection here. Now, let's go step by step. So what's going to happen is this is going to deflect down, touch B, and actually compress B a little bit. Okay, so we'll break it down. We'll start with these two guys here and just figure out what the deflection, the total deflection at the midpoint will be, and basically set that equal to the compression of that post, which we'll get to in a second. So we got these two guys. So B is pushing up on it. So I'll start with that one. So I'll have B times L cubed, which would be 12 cubed all over 48 EI. And I'll add the E and the I later. Okay, I'm just going to pull it through for now, make my life a little bit easier now. I've got those. When I get to the reaction, I'll go ahead and plug those things in. Okay, now I've got the distributed load. That one's going down, so that's going to be minus, and that'll be negative 5 times 30,000 times L, which is 12 to the 4th, all over 384 EI. Okay, so that is going to be the deflection due to the loading. Now, that's going to equal the total deflection of that. Well, not the total deflection of the post. It's going to equal 0.0002 meters, so it'll deflect down that much, and then it will compress that post a little bit. So it's the 0.2 millimeters plus the deflection of that post, and these will actually be negative. If excuse me, so this should be negative, right? Because it's going to deflect down. Okay, and then and then another negative deflection, and that deflection is going to be BL over EA, right? Because of the fact that it is that deflection. So B L is 1, E we're going to leave alone. Okay, and then A. Did it give me A? It has a diameter. I'll leave it at A for right now. We'll deal with that in a little bit. Okay, so look, notice I got this big, huge equation right here to solve for the equation. So again, what I have here is this is the deflection due to that, right? This is the deflection due to this guy, the distributed load. This is that gap, right? This is the gap, and this guy over here is delta. Okay, so that's where that all comes from. Okay, and notice it's just one big equation what I have B in. Okay, so E, oh, and these are different E's. That's a big problem. Although everything's made of steel. Okay, so that's good. So this guy is 200 times 10 to the 9. This guy is 875 times, that'll be 10 to the negative 6 in meters. Okay, and then A is going to be pi over 4 times 0.04 squared. Okay, plugging all of that in, I can then find that B equals 219,780 newtons. Okay, and again, I get that by knowing that I have a deflection of, due to distributed load, pushing back up with a point load at the middle, and that's going to equal the gap plus the deflection of the whole thing, where that deflection is also based on that reaction force at B, right? Once I have that, I can then easily plug things back in, and then due to symmetry, I also know that A is going to equal C. So basically, I can say A equals C equals 70110 newtons. Okay. So that's how you take care of that. Break it up, then knowing finding the deflection of each load, and then setting that equal to the total deflection, which would be the gap plus the deflection due to the compression of that post